Alright guys, I realized my previous video got cut off, so I'm gonna continue from where I stopped at. Okay, now before I was rudely being cut off by my iPad. Okay, I just want to talk about ozone layer. Okay, just now as I think I stopped at the part where ozone layer, as you all know, that is actually a good thing. It protects the earth from the harmful UV rays of the sun. But that is the good part. If you have ozone layer in our midst, okay, it's not a good thing. Okay, I'm gonna explain to you all later, okay, why it's not a good thing. So let's talk about the first air pollutant, okay, sulfur dioxide. Now sulfur dioxide, basically how you get sulfur dioxide is you get it from coal and petroleum. Now coal and petroleum as well as diesel fuel, okay, it contains sulfur. Now you do realize that when you get coal, petroleum and diesel fuel, you get it from deep underground. And when you have deep underground, some of the components of the rock, they contain sulfur. So when you are actually harnessing these substances for their energy by burning them, okay, what you are unwittingly doing is you are actually oxidizing sulfur to form sulfur dioxide, okay, and you are unwittingly releasing big volumes of sulfur dioxide high up in the air. Okay, so that's not a good thing. The second air pollutant is nitrogen oxides. At high temperatures, how is nitrogen oxides formed? Is basically your nitrogen and oxygen will react in the air, because your main component of the air is nitrogen and oxygen. You will combine together to form nitrogen monoxide. Now, nitrogen oxide also combines with more oxygen to become nitrogen dioxide. So these two oxides of nitrogen can be sometimes be described by scientists as NOx. Why? It could mean NO and NO2. Now, when do these reactions naturally occur? Now, you do know that high up in the air, in our air, 20% is oxygen, 79% is nitrogen. So all you need is a very high temperature. And when do high temperatures occur? Is when you have lightning, okay, and lightning and forest fires. You know, forest fires when the temperature is very hot, okay, and you have a lot of forests, you have a lot of crops, and you just need a certain friction, and then sometimes the fire will start on its own. That's where you're unwittingly burning nitrogen oxide. You're burning the air per se, and then you're forming nitrogen oxide. Okay, so but however, most NO2 pollution is produced inside vehicle engines, okay, and some come from burners in power station, factories and incinerators, because these are the very places where you have a lot of heat. When you have a lot of heat, you are unwittingly or unconsciously burning gases in the air. Okay, now then next you have carbon monoxide, which is colorless, odorless and poisonous. Its formula is CO, and just now when you've learned it in the previous lecture or previous video, carbon monoxide is actually formed from the incomplete combustion of motor engines. Okay, now how do you know, or do you know why carbon monoxide is especially dangerous? Is because it is poisonous, but yet you can't see it or you can't smell it, and there is no warning of its presence. So basically you can be in a room, you know, studying, and then I can just pipe in carbon monoxide. You wouldn't know, you just pass out from carbon monoxide poisoning. Okay, that's you have a lot of incidents where, you know, mothers actually, or brainless mothers actually leave their kids in the car to go for quick shopping. That what they knew as 10-minute shopping, and then they drag into 3 hours. They come back, and then their baby's face turns blue in the face, and then after that, the next thing they know, their baby is died of carbon monoxide poisoning. Okay, even though they leave the engine off, and then they just leave their baby like that. Okay, so please, the mothers down there, the future mothers down there, please, you know, if you're a shopaholic, please do not leave your babies in the car just like that. Bring them along. Okay, now next up we have methane. Now methane is another colorless, odorless gas with a formula of CH4. Okay, and is naturally present in the atmosphere due to bacterial decay of vegetation and other sources. So when you have your rotten vegetation, okay, or whatever that rots, okay, you actually release methane gas. Now, amount of methane in the atmosphere is increasing due to human activities such as agriculture. So, you know, when you have agriculture, your main aim is actually to get food, but you know, besides that, you have rotting vegetation, then you're unwittingly getting a lot of methane as well released. In addition, a lot of methane is also used as natural gas fuel, and now when you use it, it's fine, but the problem is some of it leak from the pipelines. Okay, so when methane is being released into the air, the problem is methane it traps heat from the sun, and when it traps heat, it gets a greenhouse effect. Now later on we'll explain what is this greenhouse effect all about. Okay. Now next up is unburned hydrocarbons. Now unburned hydrocarbons basically come from fuel that has not been burned in vehicle engines. So it has not been burned completely. Soot is one of those unburned hydrocarbons. When they burn it, there's very little oxygen, and then it becomes, you know, just hydrocarbons in vapor form. Okay, so as I was saying, incomplete combustion of octane in petrol produces carbon monoxide and water. So some of them actually escape into the atmosphere with octane, and that octane is unburned hydrocarbon. Okay. Now ozone. Okay, ozone, as you know, the formula is O3, is a form of oxygen, and it is a colorless gas. Now, as you know, ozone is a good thing, was a good thing, or is a good thing. A layer of ozone gas actually surrounds the earth at high altitude, and it prevents us or protects us from harmful UV radiation from the sun. Okay, now that is high up in the air. At ground level, most ozone comes from the action of sunlight on other pollutants. So when ozone react with the sunlight, okay, it will produce this thing called photochemical smog. Now photochemicals basically photochemical smog is something like haze, but it's at a much more dangerous level. Okay, so you find that ozone levels are particularly high in cities where you have had a lot of vehicles. Okay, so yeah, I said photochemical smog is a totally different thing than haze. If haze is, you know, just, you know, those gray color, photochemical smog is basically brown. It's a brownish haze. Okay, so you get it a lot worse. Okay, now as you know, our ozone is already depleted, okay, by CFCs. Okay, and two important examples are CFCl3 and CF2Cl2. So CFCs have been used in many things, like for example aerosol propellants, and in making foam plastic, your styrofoam boxes, and also when you spray stuff. Okay, so basically your CFCs are decomposed into chlorine atoms by sunlight high up in the atmosphere, and basically your chlorine atoms will react with your ozone molecules and convert them to oxygen. Now you probably think, wow, it converts to oxygen, that's a good thing, right? But the problem is, when it converts to oxygen, yay, it's more oxygen for you, but now your ozone layer has a very big hole there. Okay, and it can cause harmful UV radiation to reach the earth. Okay, scientists have predicted that we have an ozone hole near the southern hemisphere of the earth, where the south pole is. But good news is, some scientists actually are hypothesizing, saying that, you know, we actually discovered the mistake, we're discovering the error, and we are actually limiting the use of CFCs. So now the ozone layer is back in repair. That's what some scientists are saying. Some scientists, you know, all doom and gloom. They are saying that, you know, we are still using a lot of CFCs, and, you know, it's not helping. So they are predicting that, you know, the temperature of the earth is getting higher and higher by 1 degree Celsius as the year goes along. Okay, so it depends on who you want to believe. Alright, so I leave it up to you to read through the harmful effects of air pollutants. You must know, especially for sulfur dioxide, nitrogen dioxide, and carbon monoxide. It will be tested. For the rest, it's not really that important. You can just read through on your own. Okay, so I shall not go through this. A lot of content needs to be covered. Okay, now whatever it is, okay, if you look at the harmful effects, directly or indirectly, it will affect people's health. So all these things will become your problem. Okay, so for example, sulfur dioxide, it irritates the eyes and cause breathing problems. Nitrogen oxides irritate and damage the lungs, you know, can cause bronchitis. Carbon monoxide, it can cause death. okay, even at low concentration and stuff like that. Unburned hydrocarbons can cause cancer. Okay, ozone has the same effect as sulfur dioxide and nitrogen dioxide. And photochemical smog, okay, dangerous, can cause breathing and heart problems. So all these air pollutants actually affect people's health and affects the environment as well. Okay. See, so for the event of sulfur dioxide and nitrogen dioxide, it can cause acid rain. Okay, and methane, it can cause global warming. Unburned hydrocarbon, it will react with the sunlight to form ozone, okay, which is not a good thing. And for ozone itself, it will damage plant crops. Okay. Now, pollution from motor vehicles. As I was saying, some of the exhaust gases such as carbon monoxide and nitrogen oxides are harmful to our health, but carbon dioxide and water vapor are not. Okay, so if you look at the percentage emitted out by motor vehicles, this is the percentage. Okay, so when you want to reduce air pollution in motor vehicles, you fit catalytic converters to cars. Now, our Singaporean government is actually a very considerate government. Before any vehicles are imported or brought into our country, it is mandatory for the cars to be fitted with catalytic converters. Okay, now these catalytic converters basically are fitted into the car exhaust, where about 95% of the pollutants are removed from the exhaust gas. Okay, now how does it work? Basically, your nitrogen oxides will react with carbon monoxide to form carbon dioxide gas and nitrogen gas. Now, just now, remember the previous slide, carbon dioxide and nitrogen gas, when you compare it to nitrogen oxides and carbon monoxide, they are much more friendlier. That's what it does. So when it's being released in the carbon dioxide and nitrogen gas form, and it's much safer. Okay, so basically they are allowing air to enter and oxidize unburned hydrocarbons as well and carbon monoxide to form carbon dioxide, nitrogen and water. Now these two things you must remember. Okay, because I've seen some questions where they ask you how does a catalytic converter work. So it's very important. So please remember. Okay. Alright, I'll move on. Okay, so I was saying, sometimes you can see these taxis where it uses a clean burning natural gas and not diesel, like normal comfort taxis. Okay, so like I said, we are moving to a drive where we are using cleaner fuels. Okay, so for example, and sometimes we are and also the third one, we are reducing sulfur dioxide emissions in power stations. Now, how do you do that? Basically, we use powdered limestone added to hot gases. Now, as you all know, in your blast furnace, your limestone will decompose to calcium oxide. Calcium oxide is a basic oxide, so your basic oxide will react with a sulfur dioxide, which is acidic oxide, to form calcium sulfide. Now, calcium sulfide, of course, is much more safer to be released into the air. Why? Because when you oxidize calcium sulfide, it becomes calcium sulfate. Much more safer than sulfur dioxide. So that's about it. We've learned about the 6 air pollutants, okay, and how it's harmful to the health and all that. Okay. Now, last, I think, is acid rain. Now, acid rain is very important. There are a lot of questions on acid rain for prelim. So this is where, if you're already dozing off now, please wake up. Okay, now what is acid rain? Acid rain is any rainfall that has an acidity level beyond what is expected in a non-polluted rainfall. Now, as you know, rainwater, okay, is slightly acidic. Okay, why? Because of the amount of gases in the air. But rainwater with a pH less than about 5 is already considered as acid rain. Okay, our normal rainwater is usually, its pH is about 5.5 or 6, something like that. Okay, of course, your pH of pure water is 7, so it is virtually impossible to get a rainwater that has a pH of 7. Okay, so what causes acid rain then? Okay, now acid rain is formed from 2 air pollutants, sulfur dioxide and nitrogen dioxide. Now, sulfur dioxide, as you know, will react with oxygen and water vapor to form sulfuric acid. Okay, and nitrogen dioxide also undergoes similar reactions to form nitric acid. So you imagine you have these two acids falling on your head. Confirm jalan, right? Okay, so that's what's happening lah. So both acids will dissolve in rainwater to make it acidic. Okay, now how does it affect other countries? For our country, so far so good, touch wood, we don't have this acid rain problem. But if air pollution from one country, it can produce acid rain, and then the wind will carry it, and then after that it will fall on other countries. Okay, so for example, I think you can't see it from the animation here. Okay, for example, if China is very heavily industrialized, where it burns a lot of nitrogen dioxide, it burns a lot of emissions to give nitrogen dioxide and sulfur dioxide. That's where you will react with the water and the oxygen, and then you will have sulfuric acid and nitric acid, and then that's where the wind will blow all these fumes, and then you will get acid rain in other countries. Okay, so it's not very considerate lah. You do that kind of thing, and then you give problems to your neighbors. Okay, effects of acid rain basically, okay, you can imagine acid as a rain. Okay, it makes soil more acidic. Many plants do not grow well in acidic soil. Okay, many plants prefer a neutral pH. Okay, then your acid rain will corrode buildings and objects which contain calcium carbonate. Because a lot of buildings are made out of calcium carbonate. So calcium carbonate, as you know, it will react with acid. It will attack metal structures as well, damage trees, and kills fish in lakes or marine life. Okay, so can you think of ways to reduce these harmful effects? Okay, of course, if you want to minimize acid rain, then you have to minimize the emission of sulfur dioxide and nitrogen dioxide. Okay, so how do you do that? Basically, you burn fuels which contain little or no sulfur. So that means natural gas. Okay, and you reduce the amount of pollutants emitted into the air. So you make catalytic converters in cars mandatory. Okay, and you neutralize the acid in lakes and soil using lime. As you know, lime is calcium oxide. So you just add a bit of calcium oxide in lakes to neutralize the acidity in lakes and soil. Okay, so that's about it. Alright, so I want to talk about this global warming. Okay, before we end this chapter. Now, global warming, before we talk about global warming, you all should know about this carbon cycle. Now, what is this carbon cycle all about? Now, the world, when the world was being formed, it is such a miracle, such a wondrous thing. Basically, you have carbon dioxide in the air continually being removed by green plants. As you know, human being, all living things, when they breathe out, okay, they breathe out carbon dioxide, correct? And all these carbon dioxide is being breathed out. How come they don't accumulate over time? Because it is continually being removed by green plants when they make food, when they photosynthesize. Okay, and is continually replaced by other molecules from combustion, respiration, and other processes. So you have that kind of cycle where something is being given out and something is being taken in. Okay, so the world is balanced in such a way. Now, this movement of carbon dioxide is called the carbon cycle. Okay, now, however, with the heavy industrialization and modernization of man, it comes a problem. Suddenly, there is an increase in the amount of carbon dioxide, and with the increased amount of carbon dioxide, okay, now it's called this problem called global warming. Okay, so what is happening here? Now, if you look at the diagram, okay, you identify how carbon dioxide is being removed and how it's being replaced. Now, if you look at it, where you have your fossil, okay, when let's say if you have your animals, you will decay. Okay, let me write it down. Okay, firstly, how do you get carbon dioxide in the air? Okay, it's being contributed by plants. Okay, and then you have your carbon dioxide in the sea, where you're being given by seashells, and then sometimes you have your animals here, okay, providing carbon dioxide. Okay, now the problem is when you have animals decaying, okay, and all that, it will contribute to fossil fuels. Okay, and then after that, your fossil fuels, when man modernized and industrialized, they combust, they produce more carbon dioxide. Okay, and then after that, seashells, you know, when you have, it will give you limestone chalk. Okay, when you heat up, okay, it will give carbon dioxide. So you see, everything leads up to the accumulates to the amount of carbon dioxide that is given off. Okay, so where is the carbon cycle? Okay, basically your carbon cycle is now being disrupted. Okay, so do you think this two-way process is being balanced today? Definitely not. Okay, why? Because we are basically, when we modernize ourselves, we are upsetting the original balance. Okay, so as you look at the statistic here, okay, all the way from 1750 to 1950, everything was very stabilized. Okay, everything was gradual. Okay, gradual increase, not so much. Now after that, after 1960 onwards, okay, all the way to our current present time, okay, there's an increase in carbon dioxide and it becomes greater and greater. Okay, now this is the serious problem that is called global warming. Okay, now global warming, as you see, the Earth's surface is heated by radiation from the sun. You can't escape from it. The sun is so big. Okay, so you will inevitably heat up the Earth's surface. Now the problem is, already when you are heating up the Earth's surface, it's already very hot. Okay, you're not helping things. Why? Because there is carbon dioxide and other gases in the air that traps this heat radiation. Now when it traps heat, it will prevent much of it from escaping into space. So who gets the brunt of it? Us and all the other living things. And the gases in the atmosphere that trap heat are what you call greenhouse gases. Now as you recall, one of the greenhouse gases is methane. Okay, so you see this diagram. Okay, so everything gets heated up, and then you have your carbon dioxide and your methane. It will trap all this radiation. Okay, so your carbon dioxide, your methane, your CFCs, and your nitrogen dioxide are what you call these greenhouse gases. And these are the main culprits that are contributing to the Earth increasing temperature gradually. Okay, so is the temperature of the Earth rising? Some people say yes, some people say no, but the harsh truth is yes. Okay, if the temperature continues to rise at this current rate, by 2050, okay, we will be 10 degrees Celsius hotter. Now already at 32 degrees Celsius, we already way tahan already. By 10 degrees Celsius, 42 degrees Celsius. How? Our aircons also need to be stronger. Okay, we must perpetually on the fan. Cannot lah, confirm die already. Okay, so this is the statistic lah. Predicted rise. Okay, consequences of global warming. Not only will we get hotter, okay, our sea water will expand, okay, and your sea level will rise. So when sea level will rise, those countries that are low lying, like for example Maldives, okay, will sink. Okay, some scientists will predict that Maldives, if you want to go on for holiday to Maldives, go now, because in 50 years time Maldives will be no more. Okay, it will cause flood, and your temperature will keep on rising, where your polar ice cap will melt, and then it will cause the sea levels to rise further. And as I said, low altitude countries such as Maldives, very beautiful country. I've not been there, I want to go there. Okay, so make me go there, you know, by giving me my bonus. Okay, these countries will disappear. I don't want it to disappear. Okay, so there will be big changes in the global climate as well. Equatorial countries will experience more rain, so countries like us, okay, near the equator, and countries in the far end, North America and Europe, will suffer more drought. Okay, so how do you prevent global warming? Very simple. You want to prevent global warming, you have to reduce the amount of carbon dioxide being put into the atmosphere by, again, reducing the use of fossil fuel, you know, conserving the electricity, generating electricity using other sources, okay, like for example wind, tidal, and using hydroelectrical power. Hydroelectrical power is another name for water. Okay, and employing greater use of electrical vehicles. Okay, why? Because when you use electric vehicles, you're not emitting much fossil fuel. But some people argue, hey, you use electrical vehicles, where are you going to get the electricity? Indirectly, it comes from fossil fuel also. So it's a catch-22 situation. Okay, right, that's about it. Okay, so we talk about global warming. Before that, we talk about acid rain, and that's that for the topic. Okay, so for the past 40 minutes or so, thank you for staying with me. That is the topic in air. So once you are done looking through this chapter, okay, if you've got any questions, okay, you can text me at WhatsApp. You can text Mr. Chen at WhatsApp, and please do your workbook assignment. And with that, okay, thank you for staying with me for these 40 minutes. I'll see you in school. Goodbye, kids.